So in this video, I'm looking at the insurance rates question. So here the scenario is you're selling insurance to someone who is about to go on a trip on an ocean liner that's going to collide with an iceberg, and you're trying to set the insurance rates and the premiums, so the premiums and the benefits, in such a way that you won't end up losing money. So it's a little bit of an artificial scenario, of course. If you know that the person is going to be in a shipwreck, you probably would not really want to sell insurance to them. So here's how we're going to structure this. So we're going to write a function that's going to take the data, so kind of like the Titanic data, and it's going to take a model, and it's going to take the threshold above which you are going to sell the insurance. It's going to give the premium, and it's going to give the benefit. So I'm writing this here. So that's going to look like this. And we'll make the kind of model. So we'll just do GLM of survived, and then like age plus sex plus B class plus, let's say, fair, data equals Titanic. So the fit is going to go here, and then we'll set the threshold. So if the predicted probability for that person is like below 60%, for example, you just would not sell them insurance. And then the premium is how much they pay you. The benefit is how much you pay out in case they die. And that is the data. So we'll just use the Titanic as well. So the first thing we need to do is we need to make the probabilities here. So the predictions. So the predictions are going to be predict, fit, and new data is going to be that. And we'll do this. So here we don't do greater than 0.5 because I'll set that equals to Titanic as well. So the reason I don't do greater than 0.5 is because we actually want to look at P, right? So because in the side of the function we're always going to be using P, we can just say greater than P. So this is kind of predicted according to the model, which says if, for example, the prediction is greater than 60%, then we say true. Otherwise, we say false. So P could be anything. So if we want to be like really risk averse, we'll just sell insurance to people who have like a 99% chance of survival. If we want to be less conservative, then we'll do it differently. So let's set like a sample P. So maybe P is 0.6, and maybe premium. So just for starters, we'll set it to 10, and the benefit is going to be like $50. Okay. So now we want to figure out how much revenue we have and how much expenditure we're going to have. So the revenue is the number of people to whom we agree to sell insurance times the premium. So we agree to sell insurance if the prediction is true. So if the probability is higher than P. So that means we sell insurance to this many people, sum of breads, because the number of trues, the number of people who are above the probability threshold for us to say, okay, we'll sell you insurance, and we'll multiply that by the premium. Premium is how much you get paid by the people to whom you sell insurance. So expenditure is going to be how much you pay out. So how much do you pay out? Well, we're just looking at the people to whom we sold insurance. So that would be preds is equal to true. And who also died. So that would be and that survived is 0. So that's the number of people whom we sold insurance to, and they also did not survive. So if we do sum, we get the number of them, because this is a vector of trues and falses, where true corresponds to they were predicted to survive but didn't. And now we'll multiply that by the benefit. So that's the expenditure. So the total profit is just revenue minus expenditure. So now we can try it. So we'll say total profit. And here we can just decide. So fit. So we can say P is equal to 0.6. We can say premium is equal to 10. And we can say benefit is equal to 50. And we can say data is equal to that. So that, sorry, is equal to the Titanic. So the total profit here is 50. So can we make maybe, like, would it make sense to say P equals 55? Are we going to get more? And the answer is no. If we make P equals 55, we're really going to lose. What about if we make P equals 57? No, we're still losing. So what about 65? Oh, now we're making a nice profit. Okay, so it's like that, and you can just like play around with those values and see kind of what makes sense. Of course, nothing really will make sense because you just don't sell insurance to people who are going on a cruise that you know is not going to end well.